Okay, this is two-dimensional motion. We're going to start with the projectile motion. It says an apple is thrown with an initial velocity of 42.8 meters per second, 22 degrees above the horizon off a 16-meter cliff. So our givens are that the initial velocity is 42.8 cosine, 22 degrees. This is 42.8 sine of 22 degrees, because you think of the initial velocity going up, and it has a Vx component and a Vy component, as you can see in that little triangle there. This one being figured out by doing sine of 22, if this is 22 degrees, and this one being figured out by doing cosine of 22. So those are initials. I know that gravity is down and that the displacement is 16 meters down as well, because it actually falls down 16 meters from its original position. Okay, like so. And that should be a little more parabolic here, not so straight. So what I'm going to try and do first is find the flight time, and I'm going to work in the y direction. And so I know that the delta displacement is equal to initial velocity times delta t minus 1/2 a delta t squared. Since I'm trying to solve for delta t, actually I believe this is a plus. I don't have the equation handy right now, so make sure you check to see that this, with the initial velocity, it's a plus. And then I think there's one with the final velocity here that has a minus. Make sure you double check that, because that's going to affect the math here. So now I'm going to try and solve for delta t. Solving for delta t, I make delta d on, so I have a negative delta d plus vi delta t plus 1/2 a delta t squared. And I note that I have a quadratic here, and this quadratic can be solved by noting that this is the c value, this right here is the b value, and this right here is the a value. And so the quadratic is delta t is equal to a negative b plus or minus the square root of b squared minus 4ac over 2a. And so if I take my c value, plug it in here, my initial velocity, and plug it in here and here, and then half of the acceleration, plug it in here. Note that this is acceleration and this is an a value in the well, this is actually a g, okay? And so this is a value in the quadratic. This is a b value and a c value in the quadratic. And so doing a little bit of algebra here, I get it's a negative initial velocity plus or minus the root of initial velocity squared. Get in a little closer here. Minus Now, this section is 4 times a, which a is 1/2 g. So if I take this 4 and multiply it by the 1/2 g, because it's 4 times 1/2 g, I'm going to just write it real lightly there. You can barely see it. This 4 times 1 actually becomes a 2. So I'm just going to change that into a 2g. Then I multiply it by c, and the c value actually is negative. And so it's a negative delta d, because it's multiplied by a negative delta d. This negative and this negative combine actually to become positive right there. And then this is actually going to be 2 times a, or 2 times 1/2 g. Well, 2 times 1/2 g is actually just g, because the 2 and the 1/2 cancel. Then this and this will become positive. And so then you've got delta t is equal to a negative initial velocity plus or minus vi squared plus 2g delta d over g. This is the flight time formula. Okay, and again, you should check to make sure that this is actually a positive. Not sure. Again, if this is up here, let's make sure that this is positive in our original equation right here. If it's not, if it's negative, then this should be a negative that carries down to here and to here, and my a is actually negative, in which case this is negative and this is negative as well. But I think this is correct. Anyway, so you can figure out the flight time, just plug all that stuff in there, and you get some value in seconds. And to find the range, you actually have to move back up to the x, noting that the range is delta dx, and time you just found, because you could, flight time is going to be some number that you know now. And so, remembering also that, velocity equals displacement over time formula, so it's Vix is equal to delta dx over delta t. And so, since you're trying to solve for this, you just know that delta dx is equal to Vix delta t. This is going to be the range. Okay. Now, the impact velocity is actually going to be a little bit of work here. This is part A. This is part B. And then I'll do the impact velocity. It looks like on the back because I'm running out of space. So in order to find the impact velocity here, I'm going to have to realize that my ball, or my apple, is hitting the ground like this, and it has, once it hits the ground, it has a particular velocity. I'm looking for the x and the y velocity there. I can put these back together with the Pythagorean theorem to get the impact velocity. Okay? And so, what do I need to find? I need to find VFX and VFY. Remembering that VFX is just the same as VIX. Like this over here. It's the same, which I know is 42.8 cosine of 22. Right? And so, but now to find the VFY, I know that there's a formula that says VFY squared is equal to VIY squared let's see, what do we want to do here? Minus plus 2a delta d. Okay. Delta dy. And this is g. Now, we could use this formula here to find the VFY, but the problem is we don't know how high. Oh no, we do know. We do know that it is 16, or it might be a negative 16 or positive 16, depending on what you choose. At the end, I'll go back and discuss all of that stuff. And so, in reality, we actually know the initial velocity, we know gravity, and we know d delta dy. And so the final velocity, y, is actually the square root of this entire thing plus 2g delta dy. Once I know that final velocity in the y direction, I can take this variable and this variable up here, these two variables, and then I actually just put them back together again. So the actual velocity final is the square root of VFX plus, or squared, VFY squared, and the direction, this is the magnitude that I've just given you, the direction is tangent inverse of VFY over VFX. So I'll back up on that. So again, the VFX is the same as the VIX. VFY, you can use this formula here, in which you use this displacement here. In this case, it's 16, and I'm going to choose positive 16. And my VIY is actually going to be negative in this case, because I'll show you that in a moment. Now, last thing, we have to find the maximum height. The maximum height is found by doing this same formula as we just did, actually. It is VFY squared equals VIY squared plus 2g delta d, where this delta d actually represents the maximum height. Okay, and I only have 4 minutes left on my hard drive, so I'm going to get moving on this. The maximum height is actually this height right here. So at that point, the final velocity is 0. And so I actually make that 0. And then I solve for delta d. So 0 equals VIY squared plus 2g delta d. And it looks like I subtract this over and then divide by 2g. So the delta d is a negative VIY squared divided by 2g. This will give you your maximum height. Okay? This over here will give you your impact. But you need also this as well. Flipping back over, your range is this, your flight time is this. And then one last thing is, when you go back up to your givens and you start plugging things in, you've noticed that your initial velocity is up, your final, and these two things are down. Remember, they must be faced in the same direction. So the easiest thing for everybody to do here is to actually get rid of the up and change it to down, but then make this whole expression negative. Then you have to really remember, when you go to take your initial velocity y's, these are all y's, by the way, in your flight time. These are negatives. So example, this is a negative initial velocity. This is a negative initial velocity squared, which actually will become positive. Over here, this is a negative initial velocity squared, which will become positive. This is a negative initial velocity squared, but the initial velocity over here, this is initial velocity squared, but the initial velocity squared becomes positive, but this negative comes from the, so this actually becomes negative. So you have to actually understand the algebra here in order to use these equations. Don't use equations that you don't know how to use. Anyway, so those are the projectile motion equations. I'll put the rest of two-dimensional motion in a part 2.